Hello everyone, I am Harshit. Today I am going to explain about performance analysis of an algorithm. So, an algorithm is said to be efficient and fast if it takes less time to execute and consume less memory. So, how can you say what is the performance analysis of an algorithm? So, it takes then resources of algorithm upon the size grows when the input is increases. So, it is mainly divided into two, uh, two properties, which is time complexity and space complexity, which we are going to discuss further. So, what is time complexity? The amount of time that an algorithm requires for execution is known as time complexity, which is represented in or expressed in big O notations. It is divided into three types: best case, worst case, and average case time complexity. So, the commonly used time complexities are constant time, logarithmic time, and exponential time. So, we are analyzing how the types of time complexities are. So, as I have said before, there are three types, which are best case, worst case, and average case time complexity. So, best case time complexity takes minimum amount of time for its execution. The worst case takes the maximum amount of time for execution, and the case takes the average amount of time for its execution. So, this is works for the space complexity also. So, what is complexity? The amount of space that algorithm requires for execution is known as space complexity. Sounds familiar, right? This is same as the time complexity, but here we are using the word space. So, and it is also expressed in big O notation, and we can use in like linear search, merge sort, etc., etc. And it's also divided into three types, which is best case, worst case, and average case space complexity here. So, what are the components of complexity? So, in space complexity, the measure of space is very different, which we discuss here. Like there is instruction space, environmental stack, data space. Instruction space, that is space required in computer in order to store instruction is known as instruction space. Environmental stack is the amount of space required to store partially executed function. Data space is required in order to store variable and constants. So to calculate the time complexity, we use a formula here, which is S of p equals to C plus SP, where S of p is space complexity of a program, which we will calculate. C is a constant like a, B, C, something, and SP is a variable part, which doesn't have a fixed value. So here you can see in an example, in example one, a function called ABC has three constants x, y, and z. So the constant is 3 here. There is no variable part such as I, J, or something that like. So the space complexity of this program will be 3. And in example 2, there is a function called square and has a constant A. So the space complexity for this will be 1 because there is no variable part. And constant will have a fixed value and variable will have a like changing value according to it. So I conclude that we can design a better and best algorithm by using a less time and less space. By balancing both of them, we can get a best algorithm. Thank you.